let's do this. Do you have the information from the question down? I can draw it? Yeah, okay. So we have, it was water to air, wasn't it? Yeah? Water, air. Okay. And then we have I here, and then it changes, and then there's or here. Okay, so using Snell's law, sine I over sine or equals V1 over V2. Sine, can you still see that okay? Sine I, we don't know. Sine or, we don't know. But V1 and V2 we do know. What's V1? The speed in the water. 2.2 centimeters per second. And then the other one?
3 times 10 power 10.
Centimeters a second, yeah? So that's nice because that means that this cancel. So what are you left with here as a decimal, please?
0.73.
7.3, give me another decimal place, or is it exactly that?
Exactly that.
Oh, great. Now, what would they like to know? I think they want to know the maximum or. Yeah. So, you have sine I over 0.73 equals sine or. Do you know what the I is? No. Now, if you didn't know what the I is, then it's finished. It's easy. But they made it a little bit more difficult by not giving you the I. But that's okay, because they said they want this to be maximum. So this gets bigger when sine I gets bigger, right? Yeah. Because, you know, if I have A equals B, this gets bigger when this gets bigger. When does sine I get bigger? When I gets bigger. So what's the biggest I can make I? 90. So sine 90 over 0.73, what's that?
1.369.
1.369?
1.37.
It should be less than 1. What's gone wrong? It is water to air, isn't it? Let's have a look.
Maybe it's in degrees.
That shouldn't matter though. Show how refraction of light can light travels through a pool of water in a parallel beam is incident on a whole.
Isn't that 3 times 10 power 10 over 2.2?
It's upside down?
Yeah.
Well, let me just read this first.
Yeah.
Yes. Light travels through a pool of water in a parallel beam is this one. Its speed in the water is 2.2. No, that's right. Calculate the maximum angle which the beam can make with the vertical if light is to escape into the air where its speed is 3 times 10 to the 10. Well, I think what's happened here now, but is the answer 90 at the back? But it shouldn't matter unless really shouldn't matter. C is N over V. N over V. C is N over. Alright, I can't understand how it would matter, but I'm going to try and do it that way, okay? So if I just go back a step, sorry about that.
They did mention refractive index of 1.5.
But that's our next part. Next part. Okay, wait, come on. We'll just use the other formula. What's the other formula? N2 over N1.
Yeah.
Yes?
Yeah.
Now, but I feel like it's going to be the same because what's our formula for N? It's C over V. So it's going to be the same thing. It's going to be C over V2 over C over... The C's cancel and you still get what I just had a moment ago.
So isn't the refractive index in air is 1, so N1 is just 1?
Yeah, but...
Instead of finding C over V, just 1.
Maybe I'm missing something tiny in the question. Let me use my best English eyes. Light is travelling through a pool of water in a parallel beam is incident on the horizontal surface. Its speed in water is that. Calculate the maximum angle which the beam can make with the vertical if light is to escape into the air where its speed is that. But you said if it was upside down we get the right answer.
I'm not sure if the right answer, but I get 47 from it.
Yes, Diana?
What's the answer?
Go up, yeah? Huh? That's right, isn't it? Unless I have my formula upside down, maybe it's V2 over V1, but I thought it was V1 over V2.
Yeah.
Unless, actually, now that I think of it. Wait, I think I know what the problem is, sorry. Let me just double check something here. No, it says it there on page 5. You got page 5?
Yeah, it's right. It's right.
I don't know what the heck's gone wrong. But you said you got the answer at the back. So, how is yours different to mine?
N equals C over V. That's the speed of light over V.
Yeah, that gives you the ends.
1.36.
Yeah.
Then you make sin I plus sin R equals to that constant, which is 1.36.
But that constant is N1 over N2,
Just N.
which is what?
1.36.
Which in this case is actually N1. Yeah, you've used that ups the wrong way around. It should be 1 over N. So you would have the wrong answer as well, the formula that you're using. I have a feeling, that for my formula, if I did it this way around, it would be right. But in the book,
In
it's...
the book it says
Yes, I know. So let me just see if we get the answer at the back if we do this, okay? So what is the V2, please?
3 by 10.
3 times 10 by
3 times 10 power 10 over
2 times 10
times 10 to the...
10.
12.36.
Yeah, 1.36. So now you have sine I over sine or equals 1.36.
That's 0.65.
So if I put I as 90, what's 1 over 1.36, please?
0.725.
0.
Yeah, 0.7.
Okay, so then or is sine inverse that. What's okay? 3.5. What's that, please?
47.1.
47.3. 3 degrees. And what's the answer at the back?
27.
I don't know. But I would like to find out. Let's see. Now for the next part, well, I want you to do the next part for me. So we have our angle of 47.3. Can you look up? But now this time, I want you to do the same thing, but instead of water to air, it's now water to oil. It says in the question. Now, they give you the N for the oil. What is it? 1.5. And do you know the N for the water?
1.
No.
I'm sorry.
But you can work it out. What is it? C over...
We just got 1.36.
Yeah, it's C over V. 1.36. So it's 1.36 for water and 1.4 for, or 1.5 for oil. I want you to tell me now, in this situation, what would be the maximum angle that could happen? Okay.
Maximum angle.
Is that what they asked for? I think they're not too clear. No, they said for the next part, use this angle here. It says, at this angle in water, how will the part of the beam be affected if a thick layer of oil is floating?
But the angle is in air instead of water.
Yeah, it is, but they just said in the question, at this angle, so it sounds like they just want you to use this angle. No, I mean,
The angle we talking about, was it R or I?
was or.
What do you mean by I?
Calculate the maximum angle which the beam can make with the vertical. Sounds like the or to me, because they're talking about the light escaping. In other words, they would like to know what is the biggest angle it can escape the water at. And then they now say that there's oil on top of the water, and they would like you to use the same the angle that you got here as the I now, and they want the or. Yeah? No? You done?
You had
Let's have a look here. Snell's law. You know something, Joshua? Maybe you're right with the eye business. That would fix my problem. Hey, why are you so late?
I was there.
I'm too late for this class. You can come in for the second one, though. You can come in for the second half.
Alright.
Yeah. That was some serious oversleeping. Yes, okay. I think what you're saying, Joshua, is the problem. I think it's the I, not the or, maybe, that we can look at. Yes, I think this is my mistake from the beginning. Alright. What is the maximum angle it can make with the vertical? Yeah, I think that's why it's not working. Right, so I'll do this one again now. Right, really quick. Water, air. And I'm sorry, the question wasn't particularly clear, but in fact, what they would like is the maximum I. They want the maximum I. You can write that in on your book, okay, for question 1, max I. So the formula is sine I over sine or equals V1 over V2. So you have sine I over sine or, what was it? 1.36. Are you sure the V1 over V2? Or is it 0.73?
That's all.
Yeah, okay, so then sine I equals 0.73 sine R. If you want to make this a maximum, you need to make this maximum. What's the biggest that this can be? 1. So then what's the biggest sine I can be? 0.73 multiply 1. So now you get I equals 47 degrees, roughly. Okay.
You don't have to find the refractive index of F.
No, for the next part to do. Okay, I'm sorry, is that clear now? Is that okay? Now, that actually makes more sense for the next part, for going into the oil. So if I go on to the next part, you have here water and then oil. And what is the angle here? 47 degrees. And then it hits the oil instead of the air, and it changes its angle. So the formula now is sine I over sine R equals, now we have to use the n. What's the n formula? N2 over N1. Do you know the N2? You do? No, it's given. It's 1.5. Do you know the N1?
Yes.
Well, you can work it out. It's C over V. So this will be 1.5 over 3 times 10 to the 8 if it's in meters per second, divided by the V. What's the V? 2.2 centimeters a second. So that would be 10 to the 8 meters per second. Okay, so what do you get here, please? It's 1.36 in total. Yes. So we have sine 47 over sine R equals 1.36. So sine...
Sorry. It's 1.1.
1.102. So sine 47 equals 1.102 sine R. Okay, so now can you tell me what that is?
0.537.
0.537. Okay, and what's the orso?
It's 32.5 degrees.
Okay, can you check the answer now, please?
It's not 0.5.
Oh, for goodness sake, can you not use your calculators? What is it then?
0.66.
Thank you, Ira. 0.6.
64.
Okay, so then what's the angle then?
41.6.
41.6. Okay, what's the answer to that? 42. Okay, is there any more to that? Okay. What I'd like to do is some Snell's law from the exam. So we can do let's see, how about Snell's law is not so popular. No.
Does this always come up in the exam?
No. In fact, it's not so common for the exam, I would say. My goodness. There we go. Okay. I'm going to draw an exam question here for you, okay? Right, so let me just stop that for a moment.